Wonder if the game's going to crash when it gets to the end of the loop. I don't actually know if it's reached the loop end yet. Hello anyone that's sat through my oh, that got loud. My little intro that I have set up here. Running auto notification. So I've got my little character flying around the world, just following like a fixed loop and regenerating the world with new seeds. And astute amongst you will notice that the cactuses actually now respond to the world seed. It's obviously not particularly obvious when the whole world's generated every single time like this, but what I can do is like, no, I'm gonna turn the desert up and go min max, and just we turn the desert into the field. That'll turn all this grass into desert. Okay, a lot more desert now. So today's stream is going to be focusing on stopped. Oh, here we go. Off we go again. Bet it was that was the end of the loop because it just was failing to find the next point to go to. Let's turn the water down as well. What's that look like? So almost entirely desert, a little bit of grass, a little bit of sand, a little bit of water. So okay, basically no water. That's hilarious. Anyway, so as you can see, we got lots of different cactuses. They're all still currently in the center, so that's not much fun, but we'll work on that today. And that's kind of the focus of today's episode is going to be drawing like the cactuses so that one, they're not all in the center, and two, potentially have the ability to have more than just like one cactus per spot. Might also need to optimize the cactuses because they've run into the same issue that trees had, is that they just take so long to spawn the cactuses. So maybe I could give them like a sub mesh and then, but I feel like that's just going to be even slower because the insertion into a hash table is supposed to be O of 1 time. So it's more just about the fact of the number of hexagons that they take, or the number of vertexes that need to be inserted, that affects the speed. I don't like this. This is not good. How have I ended up with this coming back? Okay, that's bizarre. Do I even have control? No. Why do we have stretches again? That's got to be to do with I'm feeding in the seed by XORing the thing, and it's obviously giving the same seed. Like every time you XOR or something, it's giving the same number. Alright, well, I guess the first thing I should do is implement a test to catch those cases where, like, we seem to be generating the same seed over and over. And that's not good. So we'll go here. First off, why are you complaining? Because we import hex but never use hex. It's interesting. Alright. So, what we'll do is we'll go to hex ID and we're going to go test fn hex as seed. Right. And then we're going to go like within a range of, let's say, like 100. Really big chunks, you know? We're going to say let mute seeds equal a USTD collections hash set. Wait, no. Hash set. And then we're just going to say seeds is equal to a hash set new. And then we're going to go not necessarily for range in range, but instead we're going to say for ID in text editor seed dot insert. Okay. If the set already contains the value false is returned. Okay, first off, you're a hash. Nope, not a handle, a hash set. Okay, you're a hash set of U64. Okay. So then we say if not in the set. So basically, if the key's already in the set, should we actually make this a hash map instead? I was thinking hash set because I'm only looking for conflicts, but we should probably say hash map so that we can say what the conflict was. Basically, the hash map's just going to be a UID and a cell ID. Alright, and then we insert ID and if let sum old equals, so we insert the ID and also the ID itself. So basically it's hash and it's not hashed. Borrow or remove, okay, right. So what are we doing? We are checking stuff. Okay. Apparently my average view duration is 10 minutes because nobody's watched anything. It's hilarious. Okay, so what it is. So we're consuming this, so right. We will panic with dot ID equals ID, and then you are ID and alt. Okay, then we run this test and be like, why do you fail? If this, no. Well, linker failed. Interesting. Gonna work this time? No. Why can't I run tests? No, not released. We want to go new terminal cargo test. Interesting. Yeah, so the idea here. Okay, well, game started back up. F5. Okay, so it failed. Hex as seed failed. So why can't I just run just hex as seed? That's very bizarre. Why do you crash? Hex as seed. Can I test? Okay. It failed. Yes, but what did it print? It said that negative 98 equals negative 99. Okay. So has so I guess it must be because we're ORing you, maybe? So what if we did it the other way? So we turn you into U32, and you as a U32. Right, then we need to bit shift you. And then we don't need to do the as. I removed all the parentheses just to put all the parentheses back. Okay. So all we've really done is we make this one and then we OR it with the one that we shifted. Because I noticed this last night is that it was giving us weird numbers, and it's got to be because we're using like I32s and then shifting them, which is giving us a bunch of ones or something. It's the only thing I can think, at least, that would did it pass this time? Unoptimized test. That's the waveform collapse one. Yeah, it failed. Or did it fail? It's the same point. So weirdly, I need you to print. Like, okay, we're gonna say if self.q equals negative 99 and self.r equals negative 1, print. So I want to print 0b 64 of self.q and then self.r and then don't paste that. We're going to need q as U64. I guess we'll do that for both of them. So we'll do, because what I'm trying to do is just work out what like number is obviously getting duplicated somewhere, and I feel like it's like when they're converted to a U64 or something, they're just copying a lot of zeros. Not equals. All right. So then we want to go the Q as U64 bit shifted 32, and then finally we want to say print 064. I'll just copy this. Copy that down. Have I got my microphone turned on? Okay. Oh, I've got the game running in the background. Okay, and then we want to say like Q bit shifted, and then ORed with self.r as U64. Alright, so this will print out when equals to 99. this one, we'll go or self.q equals negative, what was it, 98. So this should tell us, basically, when it's equal to 99 and when it's equal to 98, it'll print out the two blocks. We should have probably printed a new line again. Something like this, just to separate them. Right, so this should have printed out a lot of numbers. So, because we're ORing them, so we've got these two numbers, which are these the base numbers. Then when we convert them to 64, they get all these ones. Right, you're getting lots of ones because you're -1, which makes you all ones. Interesting. So do I want to XOR them then? I feel like XORing them is just going to cause the same problem. Just, you know, at different numbers. Nope, it passed. Well, actually, no, it hasn't passed yet. We have to get to the right test. Exceed. And that was every single number, so I guess that was our bug, is that we were ORing them, and because when we convert -1 into a U64, it's just all ones. I guess that makes sense. So you want to XOR them so that you end up with two different numbers. Okay, that's nice. So we probably want to also go up here and be like, so XOR. So we probably want to XOR the seed as well, because otherwise, again, like as your seed approaches a higher and higher number, it just makes more of the numbers just the same. I want to go to that test though, and I want to say like, and here, 10,000. Run that test for me. Just test like a huge number of cells. I just want to make sure that there's no hexagon cells, at least within a reasonable range that you'll use, that'll get the same seed. Because in reality, it doesn't matter if they've got the same. Yeah, it still passes. If they've got the same seed, as long as they're not like you saw, everything along the -1 plane had the same seed. So as long as they're not close together. So it's got to be in here. In here. It's up here. Yeah. So we go your seed as huge and new, and then we want to be like. Oh, I'm already XORing them. Seed XOR. Okay. So apparently I was smarter when doing that. Alright, so now we run the game. Like so, and we see if all the seed, like if that's improved the numbers. Oh my, all of a sudden I'm really tired. And then we'll go into working on the deserts. The issue with the deserts is adding too much complexity, and you suddenly become like. Oh, I have to turn all the other stuff down too. Okay. So we'll go like, hey, you're 0, 0, and you're. No, you're dry desert. Dry deserts don't have calculus. No, minimum, maximum. No, okay, so what are we looking? What do we need to turn down? Forests, apparently. Which I find interesting, because that, even though the the desert takes up most of the map, most of the range, so it must be a normal distribution, as in things closer to the middle are more likely to occur. Alright, so we want to go like forests. Oh, there's the island. We turn the island into... No, 0. Turn the island off. Draw the map. Okay, they just turned to water. Turn the lake off too. Okay, so that should put the sand as being the most common. Okay. Look at it go. I really can't tell if they're all very much the same cactus. It's kind of why I need more variety in the cactuses. It's hard to tell at a glance, since a lot of the cactuses look the same, regardless of you know, what their actual shape is. Too much similar. Interesting. Go up to the top. Just gonna turn off my fly map, and I guess we can just use this camera. Oh. This one. So we're gonna go to like ID 0. So with it, because it's any chunk, isn't it? It was just over here that we really noticed it. Probably because as the ID got higher, the number became more clearly mistaken. So it definitely doesn't appear to have those straight lines of like the same hexagon. It's also, it's render distances, because I'm using a different camera than the one that the render distance is calculated from. It's all disappearing on me. Yeah, I mean, I'm going to definitely say that we've fixed that for now, that there's not just large rows of the same. Okay, I thought I saw a bunch then, but they're actually not. They're different. See? They're just short. Anyway, let's go back to working on the code, and I've turned the fly cam off for the auto fly cam, so I'll be able to fly to specific points next time I run the game. Anyway, so one thing to do is we could, for one, remove the guaranteed cactus, since, you know, we don't need a cactus in every square, but for debugging purposes, I think it's a good idea to keep the cactuses. So what I want to do is probably go Blender, I guess, and work out like how big is our cactus in terms of, if we were to spawn more than one cactus in a scene, how many cactuses could we do without like the map just being cactuses? Or how far apart do we have to make each cactus? So if I shift duplicated you, grabbed you, went 0.3, I guess, does that overlap? Yes, that sticks over the edge. So 0.3 is too much. I guess it's not 0.3, 0.3. 0.3. Okay, so 0.3 is over the edge, so it would be 0.25. Okay, and then if we rotate you, you would intersect with another cactus. So 0.25 is a good point to have the cactuses, but it does mean that we want to have like a trifold effect of cactuses, in that if we've got a center cactus, we probably don't want any neighboring cactuses, or like any other cactuses. And if we've got an edge cactus, we can have like up to 3 or maybe 4. I'm gonna say 3, and we'll just got some patterns. So like you have either center cactus, left right cactus, a 3 cactuses, or maybe 4 opposite cactuses. So I guess what we can do is go like so we want to be like enum cactus shape. So we're going to have center. We can have 1. We can have 2 op. So we want 2 op. 2 S1. So single, 2 single spaced, 3 single space, 3 single, and then maybe 4 pop. So that would give us like, was it 2, 4, 6 different types? Or I guess we'll probably get rid of the center, because the center is just a single, but in the center. So what I'm thinking is I'll probably do something like, I don't have trig functions, which means I can't rotate by an arbitrary number. I'd have to do multiples of 60. But we could go, if it's 1, move it a little bit. If it's 2, so 2 opposite would be like move 1 positive, 1 negative, and then rotate them. And then 3 would be like move 1 up, rotate it 120, positive 120, rotate it negative 120. So then you've got the 3 spaced. You don't want them to be exactly spaced, so I guess you would take 1, move it a little bit, move it a little bit, rotate it, rotate it. Okay, well, I mean, that could work. And then obviously the 2 single spaced would be move 1, notice 90, 120. 120 would give them opposite. Yeah, so the 2 opposite, okay. So we want an enum iterator on that too. We probably also want to like import cactus shape and fn gen underscore cactus, and this would take in RNG, which is going to be right, and you need to be P, don't you? Well, I guess no, you don't. You could implement that down here and say P, and you will return a cactus type of P, cactus P. Well, I guess you would return a vector of cactuses, and then the RNG is a rand. RNGs. Let's do the RNG. Okay. Yeah. So you need to be vertex position. I think that's what cactus requires. No, cactus requires P where. Cactus needs P where P inherits vertex position. Alright, so type parameter P is not constructed by the impl trait, self trait, or unconstrained. Okay, so no. Okay, fine. We'll have a cactus shape P, and then we'll just say get cactus shape. and then, yeah, cactus. This P is never used. Do we just say that A has phantom data? No, because it's gonna. So I don't want to give you a generic. Why? Yep, so why can't I just do this? Like, why? This constrains it. So it's saying that... Okay, could we instead import cactus... Import cactus P where... Is this how we constrain like that? Okay. Mismatch type P. Okay. So we're going to first return none. To do. Okay. Then we're going to go. It's going to take in self as well. Self. Alright. So we're going to match self. We'll just take in self. We're not even going to. Okay. And then we come down here. We go, okay. So if we have one cactus, we need to do some fancy stuff. Right, so we need to like return each cactus and I guess an offset for each cactus. Which is going to be a rvec3 of P. Of fixed P. Okay, the generics are getting a little bit out of hand in this stuff. Alright, so generating one cactus. If there's only one cactus, then we have the ability to basically just slide the cactus. So we want to say like offset. Let offset equals an rvec3 new, which is going to be come up here. Cactus. So best idea is probably to also take these out. That'll speed it up. But anyway, we're gonna pick U. We can probably say new. Okay, so a fixed. Okay. So, z of 0? Alright, we don't want a z of 0. We want a y of 0 there. Fixed id. P. H. I'm gonna chat and say H. Okay. Bizarre. Alright, so for now. So, what do we say? So each hexagon, each cactus can either move, so we would probably want to say RNG dot gen range from so in a 1, it can be from 0 to 1. Gonna blend it. What is the maximum that you can move and still be inside? So we said 0.25. So in theory, cactuses could go further, and they probably should go further. So I guess it's you, because if their branch sticks out into another cactus, it's a little bit annoying, but it's like the odds, depending on how common deserts are and how common cactuses themselves are pretty, you know, yeah. So we can put you up to 4 and still have you in the cactus, because if you go there, you're actually like in the next cell over. So we should probably do like 3.5 or 3.6. Okay, so gent range 0.36. Okay, and okay, so if I happen to move you 0.36, and then I was to rotate you, right, I would need to go in here, feel like, grab 0.36, and then rotate, then grab you and rotate you. So you would move around internal to the hexagon. Okay, cool. So let's undo that, get you back there. Okay, so we just want to offset your X by that much. RNG is not mutable. Okay. So first off, your RNG is going to be a mutable reference. Okay, so with 1, we generate 1 offset, and we generate 1 cactus, which is just going to be cactus new. So I guess we just go vec offset and cactus no. Okay, so you just return a single cactus. Okay, why mismatch type? Oh, because it's supposed to be the other way. It's cactus offset. Alright, so if we generate a single cactus, we just spawn a cactus, shift it around. Go back to blender. So we should probably do this with the cactus stem, a little bit more obvious. So we get a cactus, we go, yes, move that way so much, and then we're gonna spin it an amount. That doesn't work because Blender's rotating from. I'd have to change it to this. Cursor. So if I grab you and move you here, then no. Interesting. I thought there was a way you could spin around the cursor, but yeah. Okay. Anyway, so it's going to move it out. It's then going to rotate it around. I wonder if the rotation around code should probably be handled outside. Like it should be each cactus gets rotated. In of itself? No, because the cactuses do the rotating. So you'd need to calculate the offset for the cactus. Okay, so this returns a cactus. We could then give, I guess, each cactus an offset. That would be a rotation. Okay, so well, I mean, why not just say like offset dot? No, because we need to rotate the mesh. I guess no, the offset. So we go to the rotation code. Where is that? That's under you. No, we don't have it. Wave mesh. Wave mesh. Rotate. so I should probably copy this into our where is it? Vector. In here, we're going to over here we have new, and we're going to have rotate, which takes in mutable self and t. Okay, and then we're going to say let position equal self.x self.z self.z and self.x. Okay, multiply them, and then self.x equals x and self.z equals z. Okay, and this is rotate around the y. Okay, so rotate you around the y. So now we have an easy method of rotating, or at least an easier method. So what does it? So we want to say like offset dot so say let sign equal fixed ID P from rotation sign is going to be we want this would definitely give them a little randomness around them, so we could go like rng dot gen range 0 through 6 let cos equal fixed ID p rotate cos, because to rotate them by a fixed amount by 0.6 you have to rotate them by the same sine and cos in the lookup, because obviously the second one is the same, and then and these ones just cycle between 1, -1, but they also have two duplicates, which is because they're supposed to pair up. And so now I'm sort of just saying like, hey, pick 2 of them, and they should, because they're all less than 1, mean that it'll always end up inside the hexagon, but sort of not necessarily rotated around the hexagon by a fixed amount. So let's rotate y by sine and cos, and then return your offset. Okay, you're not mutable. Okay, so for now, we're only going to let cactus shape 1 exist. And then up here, we go, hey, cactus. Instead of saying cactus new, can we go for cactus underscore offset in cactus shape 1. Okay, then we want to say, so it's, oh no, it's not, it's cactus offset, it's cactus and offset. Cactus and offset. And then we say cactus dot, I guess it's just this, cactus dot build. But we need to change our cactus shape is dot dot gen cactus with RNG. new origin. Okay. Each of these needs to be returned. Alright. And then we need to return OK. Alright. So we need to say that this offset, so cactus underscore offset. And then we're going to say cactus offset and offset, add it together. Okay. So this should in theory test single cactuses, and they should all sort of just be around. And this also not going to be necessarily a perfect representation of what the map will look like, since these cactuses are, you know, ridiculously dense. Like there's guaranteed to be one cactus in every single cactus, in every single desert tile, and that's just, you know, not how the actual game is going to be. So if I go here, 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 and then go like, let's draw the texture. So the thing that we need to eliminate is first off the fill grass. So fill grass. So take that to 0, 0. Let's take this all to 0 and go. Oh, I was not expecting that. Oh, because I need to take that. Yeah, that shouldn't crash, but I need to specify that a fallback is actually a fallback. The reason that crash happens is because I make the assumption that there is always going to be at least one map tile, which in this case is this one, that covers every single possible range, and therefore allows for, you know, like if it doesn't have any other tile, it'll be grass. But that obviously causes an issue if I remove that tile, since it assumes there'll always be at least one tile that every cell can be. In theory, you don't need that tile if the rest of your cells cover the entire range, but if they don't cover the entire range, it crashes. So, not the smartest idea. We'll turn off record. Okay. Anyway. Lots and lots of cactuses. And are they still in perfectly neat lines? They don't seem to be. So that's good. And they don't, like, they're not overlapping. Well, it's a lot of cactuses. Okay, so I guess we'll get to work on making like a cactus 2 now. So the way cactus 2 is going to work is just, I guess, take, so 2 opposite is going to work like this. We take exactly this code, and then we say offset, and then we're going to duplicate. So this is offset underscore 1, and then we're going to duplicate that down, and we're going to say offset 2 is equal to negative 0.36 to 0. So this one will generate a second cactus. We should also probably make these have like a little bit of buffer room either side, just so that they don't, if there's 2 cactuses, they definitely can't spawn in the center, maybe even 0.1. Because I think 0.1's like as much as the cactus sticks out. So we then rotate offset underscore 1, and then we also offset 2 gets rotated by the same amount. So that should result in 2 cactuses opposite each other, because they'll you know, one's positive, one's negative, and then rotate them both. So then we just offset 1, and then generate a cactus and offset 2. All right. Oh, no. What are we doing? We are restarting just to see. No, that's running the benchmark. Don't run the benchmark again. Okay. So cactus. Oh, that's what we were doing. We were setting it to spawn. To always spawn 2 cactuses. So this isn't going to reveal anything because 2 op. And then we're going to say generate that. I think for picking how many cactuses to spawn, there's obviously the approach of just saying like the desert has the options of spawning this many cactuses. Did it work? No, wrong one. Running benchmarks again. Go away. The issue with just like selecting like one of each is you'll end up with there's always going to be a lot of cactuses in any cell that can have cactuses, because 0 is what's 10% of the time or something. So these should all have double cactuses, and they all do seem to have 2 cactuses opposite each other. See, 2 cactuses opposite each other. So this obviously ends up with a lot of triple cactuses together, but the only reason that's happening is because every single desert tile is spawning 2 cactuses opposite each other, which, you know, results in, you know, sort of every tile that meets has a chance, a significantly higher than normal chance of having 3 cactuses together. No, U to 0. It's a 5U. This should make us bigger deserts? No. It's got to be the island that does it. Okay, and then we need to get rid of like the lake. There we go. Should really make that like a file that I can edit as opposed to specifically like something I have to keep entering. So, oh, that's just a different. That's a sand tile. I figured you can still spawn sand tiles. Yeah. So each cell seems to have 2 cactuses in it, and they don't seem to be particularly overlapping. No, actually you're not. It's supposed to do that. Yeah. So I picked nice numbers that mean that like they can get close together, but they don't overlap, which is good. This cactus has 4 arms. Do they always seem to have 4 adjacent arms? No, you don't. This is what I mean though. It's like, there's 2 colliding. Because I'm like picking the number of arms, linearly, like you have the same odds of having 0 arms as you have 4 arms. The mean number of arms is just like ridiculous. So what I need to do is like come up with some kind of linear, like not linear, I guess. A pick more with lower numbers of arms kind of approach, or probably like a logistic curve. So the odds of having 0 arms is low, the odds of having 4 arms is low, the odds of having 1 or 2 arms is high, or like the odds of having 2 arms is high. So 2 single is going to be interesting to implement because, well, one, I can't just drop them. So what we'll do is we'll just generate 2, and again, like in these ones, because there's 2, we don't want them to be able to be in the center, because that would mean that if they spawn at the center, they're going to guarantee a collision with each other. So basically, they're both going to get generated, but then we're going to offset 2 rotates by the sine of 0. Is it 0? Who knows? Okay. The values in 0 are 0 and 1. Does that rotate you? No, because that's going to be 0 degrees. So we want to rotate by so we're going to rotate them so that they're 60 degrees apart, and then we're going to arbitrarily rotate them. Okay, so that means there is another type of 2. So there's single and double. Okay. So match self. So single and then cactus shape 2 double is going to be exactly the same as. So let's put 2D for now because we're going to make sure that 2 single works. But 2 double just literally put 2 here because they're rotated 2 sets. 2 single. Okay. Then we're going to say, and I might actually not do 4 because I feel like 4 is going to be too many cactuses in a single cell. Because as you can already see, when you have lots of cells with cactuses in them, the density of cactuses is already basically like having 4. Or like 3, I guess. But in an offset grid, because the 2 opposites can end up lining up so that you have 3 that are close together. So again, we have to go into here. Let's maybe just try turning the forest. Okay, turn the lake off, the island off, turn the desert up, and the grass off. Alright, first off, did that take too long? Ooh, it's starting to slow down. It's still way faster than it needs to be. It's 2 milliseconds. It's just that I'm only able to do 10 chunks per frame. But it's, I've almost halved the time by making it all cactuses. Or doubled the time. Anyway, so this should result in lots of pairs of cactuses. These seem too close together. Nope, pairs of cactuses. The issue is I feel like I want to pick a number and rotate the whole cell rather. So with the singles and even the doubles, it kind of made sense to jitter them. But these, I feel like I need them to rotate and keep their spacing. So what we would do is, instead of making this like this, we would say let rot equal. It also, will speed up the generation a tiny amount because we're not calling the random number generator twice. Anyway, so as I'm saying, these are supposed to be paired. So on the single, and I think even the 2 double, it looked fine. But now they're going to rotate by a fixed amount because that makes more sense. Oh, I've had the game open. Anyway, so what I was saying is I've just generated the random number on its own and then used it to get the same index into both arrays rather than having a different index both times. This will also probably result in nicer numbers because, as you can see, this one has 2 duplicates of each number, and I think this one also has 2. 0.5, 0.5. No, so this has negative and positive. So these all but the 0.5 and are the same. So it has more chances of getting the same combination, I guess. Anyway, we're going here. So turning this one off, turning this one on. turning this one off, turning forests off, and hitting F5. That should be enough desert. Nope, apparently not. Lake off. Okay. I feel like I'm just turning everything else up. Island, please turn off. Okay, I'm gonna go F5. Okay. So, does that look better? So, on the single island, we have lots close together. See, a pair. And then a pair. They're a little bit too close together for my liking. Like, it's only like luck that these two aren't colliding. These two are colliding. But what can I do about that? Not really much. Because the only thing I can really do is put them, make sure that they end up further apart. The only way to do that is, I guess they're both generated independently. We could tweak their numbers a little bit. So we can say like, you get to be like a little bit closer to the middle. So just trying to think. So you get a little bit closer to the middle, but you can't go as close to the edge. So I guess we'll do 6. So that should just sort of result in them staggering out a little bit more, since the overlapping sections are all reduced. Okay, I'm gonna call that good for the 2 single, and then we'll go 2 double, and we'll just see what this looks like. Because 2 double I think is gonna look better than 2 single, just because like my big thing that I don't like is that the cactuses are basically touching each other in the 2 single, whereas the two double are going to result in the numbers being a bit more skewed. I'm also thinking, like, how do I get them to generate numbers that aren't going to be like, I don't want to use the RNG too much for generating the numbers because it's slow. So doing something like a weighted distribution is, you know, slow. Okay, so we want to turn off this rule, turn on this rule. It was like 6 and 7 need to go. Okay. Turn this off. Oh, look at that. We need to go find a single. I don't think I updated the thing, did I? No. Okay. 2 double. Right. I'm also gonna say I'm getting tired of constantly having to adjust the world like that. So pretty sure in here I have a bit of code that removes the rules and just sets them all. I have this big chunk of commented out code. I should probably get rid of that at some point. It's just old stuff. So now we're gonna do a bunch of work, and then we're gonna neglect that bit of work. So comment out adding all the rules and just assign the new map. But we want not we want not 1, but instead, what is desert? So 0, 1, 2, 3, 4, 5. We want number 5. That should, in theory, mean that we only spawn deserts on the entire map. What was I? So we're looking at deserts. So it should just be cactus fields now, which is, you know, somewhat hilarious, but also. So F5. Yep, just a field of desert. Which means I can't look at a single one on its own. But anyway. So they do seem to be clustering nicely. We're getting nice cactuses. I probably should, change the range of sizes that cactuses can do. But again, I need like a logarithmic curve or something so that I can say like, hey, generate me a number between 0 and 1 where you're more likely to be 5 than 0 or 1, like 0.5. Just so that like the size of these is more likely to be medium, but not impossible to be large. So it shouldn't be too hard. I've just got to look into the Rand crate because it does have standard distribution and, or not standard, equal. Something in how it generates the numbers. Anyway, so that's our 2 double, and then we're just going to copy the 2 double to the 3 single. Because again, like the combinations mean that we want it to be more likely to be 1 cactus than 2 cactuses. But the statistics of it are there's more ways to generate 3 cactuses than there are to generate 2 cactuses. So same difference again. We're going to duplicate you down. And we're going to say, hey, you generate from like potentially 0, but only up to maybe, I guess 25. But we would want to kind of shrink this away and say that you're like maybe 0.15. No, so you'd be 0.05. So you'd be 0.1. But I want you to always spawn sort of close. The one in the middle. The one in the middle I want to always spawn short. And the one at the edge I want to spawn far away. And then, so that would mean we want to rotate. So we rotate you. So we rotate 2 by 2, which is hilarious. And you're 3. Alright, so you're the one that's always, so you're the middle one. And so we want to rotate you by 2. Alright, so I guess we want to rotate 1 by 1. And then 3 can not get rotated. Okay, 1 by 1. Okay, and then so we rotate 1 by 1, 2 by 2, and 3 stays in place, resulting in 3 being the edge, 2 being the middle. No, that's not right. We want, no, 2's gonna be, no, we want 2 to be the middle. Okay, interesting. Also, this is 3 singles, because we could also do 3, three doubles as well. So this is 3 singles. So offset 3, and then we want to say offset 3 dot rotate y sin and cos. And then we also want to generate another cactus, offset 3. Offset 2. No, offset 3. So how does this work? So 1 is the biggest range, I guess, kind of. It gets close to the middle, it can get close to the edge. Anyway. That'll do. It'll just give a little bit of variance. Offset 3. Scope. 3. So that should give us a, and then we want, I guess, 3 double as well. 3 double. And then we're going to come down here and be like, all this code is also applicable for 3 double, but we just need 2. I'm going to test it on the 3 double just because I feel like it's going to look better, but we want you to be 2, you to be 4. Actually, I might flip that. We'll make you 4 and you 2. You 4 and you 2. Just to give it a little bit of spice, and we'll do 3. So now the I've sort of shuffled around the ones that are different distances, so that they end up being sort of all bizarrely spaced. And then for op is we're going to do 2, and then the other 2, and then rotate them by a weird amount. Okay, so first up we have to come up here, and we need to go like 2 op, then we're going to go 3 double. Go. Okay. I guess while I wait for this to come up, I'm going to go rand, not standard distribution. Because it's gen. Okay, F5. We go, okay. First up, that's getting slow. We're already up to 3 to 4 times slower than before. But we are generating a lot of cactuses. Like, look at the density of cactuses. Yep, they do seem to be opposites. It's a little bit scary. They all seem to be in clusters of 3, because in theory they could all end up offset, but they could just be that there's just so many. Then we got like this cluster that's all touching each other. Like they've actively end up inside each other? No. Okay. Interesting. Alright, I guess we'll just do the 4 quickly, which is just going to be the same as the 3. But obviously with a 4th one involved. And then I'm not going to do... Actually, no, fuck, I'm not even going to do 4. It's just too many cactuses, in my opinion, to have in one cell. So there's no 4. You either have 3 next to each other, or 3 spaced out, 2 opposite each other, 2 next to each other, 2 120 degrees apart, and or 1. So the final thing is it's this gen range. This is what I want to go. So uniform sampler, sample uniform, rand sample, sample, rand.rs sample logistic. No, okay, rand. I want to go to rs. Okay, in their docs, logistic curve. Okay. Do you have anywhere in your docs the words logistic? No. Uni. So, distributions would probably be the spot to look. Distributions. What are there? Weighted index. Distribution using weighted discrete items. No. Sliced uniform. Standard. Okay. Yeah. So for the arms, we want a standard distribution. So when I gen range, where T is standard distribution, so how would I gen standard struct standard distribution? Standard. Okay. I do not understand this at all. So, does it? We want the number of arms that our cactus has. So we have a 10% chance that it'll have no arms. So that's the problem is I can't just do an iterator. Which is annoying. So there's a 10% chance of no arms. And then we want to go like gen ratio, return a boolean with a of number of new and being true, i.e. 2 over 3 has a chance, or 60% chance. Okay, gen range. Gen returns a random value supporting a the standard distribution. Gen self t distribution tuple arbitrary fill. Okay. So if it's going to be a standard distribution, we would need to gen like an F32. This is going to get really slow. Times 4 dot round as u size. That should mean that they're statistically more likely to get lower numbers. So the energy method is able to generate arrays up to 32 elements and tuples up to 12 elements, so long as all elements can be generated. For arrays and integers, especially for those smaller element types, it is likely to be faster to instead use fill. Okay, I want to fill an array. So randomly return values supporting the standard distribution. Okay. So so I want to say like rand gen from range. So we should expect to see less. I immediately look at a 4-arm cactus. That monstrosity has like 8 arms, but I don't think that's the. It's just multiple cactuses. Let's go back to single cactuses. This is the beauty of this, isn't it? Single. One cactus. And then if I regenerate with one cactus, it will be more clear how many cactus there are. So you have a lot of arms. We also probably want to generate when we go to cactus. Gen cactus. Okay, so the height of a cactus is going to be modified. Build new cactus. Okay, so the height of a cactus is going to be gen rather than gen range. And then times 0.5 plus 0.25. I'll just quickly close my game so you can see what I'm talking about. So I'm just gonna undo it. So gen range uses a uniform sampling, which means that the odds of picking any number in that range are exactly the same. I'm going to use a normal distribution. So apparently the gen is a normal distribution, and Control Y. Continue. Okay, which is this. So what we're doing with a normal distribution is we're basically picking a number that's more likely to be 0.5 than any other number. And as you get closer to 0 and closer to 1, the number is less likely to be picked. Let's go get Google to help. Normal distribution curve. Okay, I'm going to pop this in here. Images. Okay, so in a normal distribution, most of your numbers fall, like 68% fall within this range. And then 90% fall within this range. So it'll be very rare to have numbers up at this end. And then to convert that back into a range, we first off times it by half, which means that at 0 we get 0, at 1 we get 1/2. And then we re-offset by our minimum, which is, so basically the difference between the minimum and the maximum is times by the range, and then the add the minimum. That should reset our height back up to type annotation needed gen F32. So that should mean that the heights of our cactuses are more likely to be the same length than they are to be ridiculously tall or ridiculously short, but it's still possible for them to be ridiculously tall and ridiculously short. It's still a thing that they can do. They still seem to be a lot of ridiculously long cactuses. I think that's actually that'll be the arms. So that's our cactus height doing that, but we actually need the arms, which is apparently, we shuffle, which arm? Okay, so we need to go to the, because we call like arms.pop.xp. When we build the cactus, we go through each arm. Yeah, so the arms also need, when we, gen and arm. So we need to, so they can be between 0.1 and height. Let's go to the cargo format, please. Can you, like, any chance that you're gonna do what I want and split this up so it's easier to, yeah. Good job, cargo format. You did exactly what I wanted you to do. Okay, so length. You might. I think the height, I'm not going to bother. It's going to be, up and down. But the length of the arm definitely needs to be, gen. So it needs, I just need these two numbers cut. So it needs to be gen and F32 times by 0.75 plus 0.5. Alright. Okay. Minimum minus maximum. Okay. So that should generate more reasonable length arms. No, not format. Okay. did it generate more reasonable length arms? I have no idea. It still seems to be generating a ridiculous number of wrong length arms. We should also say that the height is more, so like 0.6, 1. You do say you generate a standard distribution. Interesting. I don't know why it's still generating that. It's going to generate height. And so the length of the arm. And then the height of the arm, we don't really want to be a standard distribution, but I guess we kind of do, because we want it to be closer. So gen F30, F32. Like, we want it to be closer to the middle than to the ground. But I feel like this one I want to do things because I want it to be more likely to be close to the ground. So we'd want to times u by height. So basically generate a range between 0 and the height of the object. I guess we want to go like generate a range between 0 and minus 0.1, and then we add 0.1. Alright, wait, so add 0.1. So that means it'll always be 0.1 off the ground. At least. At the very minimum. The closest to the ground it can get is 0.1. So maybe 0. And then the closest it can get to the top is 0.05, because if it generates at height, you can only be slightly lower than the height plus the offset. So maybe make this a little bit more. Maybe 2. Okay. You again couldn't see what I was doing. Gotta stop leaving the game running. So I've just made the height of each arm also a standard distribution. Also, it doesn't feel like it's working. Random number value supported by standard distribution. Like the fact that there's still so many ridiculously fucking long arms. That might have something because I'm supposed to be multiplying by a half. So maybe let's go with like 2.5. 1.25. Right, and your length would be your minimum length is going to be 0.1. Right. I think I just made all the cactuses shorter. Yes. So we kind of want to do the other way. We want the height to be from like 6 and then the minimum height, a minimum height of 0.2. And then okay. And then we want to say that you are like likely shorter. Because the thing is the arms can be off the ground, which means that the arms kind of get the combination of this height plus that height. So that's why the arms keep ending up way taller. Even with a standard distribution. They just end up with weird number offsets. It's like a combination effect. They still don't feel like normal distributions. Like, there always seems to be some ridiculously high ones. How do I shrink standard deviation? That's my question. Gen T width standard deviation t. Does rand have, it has like a trait, right? RNG. RNG core? Next, okay. RNG, right. Are we using rand's RNG? Like, RNG, oh, we are. So yeah, you're all the possible things we could call. Which is gen. So, standard. Okay. The floating point of standard generates a random value from 0 1. The half. Your i.e. including 0 but not 1. All values that can be generated are of the form n times divided by 2 from the 24 most significant random bits of it are used, and probably the 53 was open enclosure, stand enclosure. Okay. A generic random value distribution implemented for any period of time usually generates values with numerically uniform distribution and with a range appropriate to the type. Numerically uniform distribution. So the fact that it calls it a standard, it just means it's standard. That's not what I copied. How did I end up copying that? Numerically uniform distribution. I'm assuming that's going to say a flat images. Yeah, it's like a flat distribution. It's just a flat line. Numerically uniform. Okay, so what other types of RNG are there? Okay, custom implementation. Standard distribution may be implemented using for user types as follows: distribution, random distribution standard. For example, from entropy sample standard. Floating point implementation standard generates a random number in the half open, i.e. from 0 but not 1. All values that can be generated open with sample. Open close 0 1 will sample from 0 to 1. And gen range 0 1 which will also sample from 0 to 1. Note that open 1 and gen range which open 1 and gen range which is uniform use transmute based methods which yield 1 bit less precision but may perform faster on some architectures on them. Okay, so we gotta go to rand distributions. No, I just want to go to your distribution. Weighted, binomial, gamma, float, normal, standard normal. Okay, I think I found what I need. So I need to come up here and be all like, so we would want to go distributions, standard. So standard is not a normal distribution. Okay, samples float point numbers according to the normal distribution, N0, aka a standard, normal, or Gaussian. This is equivalent to normal, but faster. The normal for the generated normal distribution implemented via, okay. So, I then want to come down here. We're going to go, okay, well, first off, I'm going to give a shit about all of this. For now, these can all be the same. We're working on changing how cactuses are generated. So, instead of sampling this, we would say standard normal dot. How do we do it? It's just dot sample. Yeah, dot sample. And then RNG, and this will return a float. Okay. Why are you saying this? Warning, use of deprecated unit struct. Rand distribution standard move to rand dist r crate. Okay. Nope. Rand dist r. Nope, spelled wrong. What crate did you say it was in? Rand. No, I've got to comment this out now so that it will tell me what crate I need to include. Okay, so what was it? It was moved to rand dist r crate. How is it not copying? You suck. Rand dist r. Right click, copy, 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 copy. Okay, rand dist r. Okay, and then we're going to go up here and say instead of random distribution. Okay, we're going to use rand dist r. Come on, Rust Analyzer, finish analyzing. You've got this. Gotta give props to my viewer who is patiently watching me struggle around with stupidity. Or you're just enjoying looking at cactuses. I should really turn the random fly cam on while I'm waiting for shit to compile. The random distribution crate. Okay. Generates random samplers for probability distributions. Re-export. This crate is a superset of RAND distribution models. So the RAND distribution model documentation for the overview of this core distribution trait and implementation. The following re-exports: distribution, standard, numeric, uniform, open, closed, open, open. Distributions. This crate provides the following probability distributions. Go away. Where'd my text go? Give me my text back. I was reading that. Normal? Why is it? Okay, that stuff. You're broken now. Why have you broken? Proc macro. No, fucking not built yet. Yeah, shut up. Okay, distributions. This crate provides the following probability distributions related to real value qualities that grow linearly. Errors, offsets. Normal distribution. Standard normal. As a pre. Okay, skew normal. What's skew normal? Okay, interesting. Corti. Okay, so what does it say about skew normal? The normal distribution, location, scale, shape. Skew distribution is generated of a normal distribution to allow for non-zero skewing. Okay. if the distribution function for scale is greater than 0f, okay, is from end to distribution. Location to scale to shape 1. Huh. Finite or and larger than 0 must be finite. I think technically I'd want a skew because I think skew is doing normal. Mean standard deviation. Standard normal. Geometric. What is a geometric? Geometric curve. Okay, so standard normal. Let's save stuff. So third random sample. Okay, so we want to go to like RNG. Yes, so like, so is it like RNG dot sample and then standard normal. Okay. And then so sample needs to know what T is, what T distribution to. Okay. F32. Hey, we do. No. Method takes in 2 generic arguments, but only one was specified. The distributor I gave you, thank you. So this is nice. So we would obviously want to do this and this, and you know, sample. Is there a sample range maybe? RNG dot sample gen range. No. Sample distribution. Okay. Interesting. Anyway, just doing this for now will result in what I need. So basically multiplying by 4, rounding. It's just very slow. I mean, it's not like it's going to do anything different. Minus 2. Okay, that should, in theory, swap to using standard distribution. Dun, 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 dun. What time is it? 4:30. Okay. Probably time to start wrapping up the stream, but I've got like another half an hour. Okay. Okay. Interesting. Why did this fail? Sample range. Required by the bound sample range. Sample range. Gen range. Gen range. Okay. Let's go to where it is. Where is this? RNG.gen range. Okay. The trait bound integer sample range. Sample uniform. Gen where T is sample uniform. Okay. But why don't you know? I've obviously imported something. What do you mean? Sample range is not specified. Required by the bounds. Okay. But you know what it is, right? Like rot. Rot is a U size. Okay. What have I done? Gen. Oh, wait. How have I turned this into? This is what I was trying to do earlier. I don't. What have I done? How? It's not really what. It's like how did I do this? Because I was trying to do this earlier. Because this one, I'm pretty sure you can specify like what sampler. Sample range, where R is sample range, where T is sample uniform. The answer is no, you still can't sample range. That is very bizarre. Why did the whole fucking thingamabob change? The whole API changed. I didn't do anything. Unless I've wildcard grand, haven't I? Which means that it's probably updated. Like it was probably using an older version that had gen range be, you know, a specified, you know, min max, and now it uses Rust's range bracket. And obviously, while I was wildcarding it, it wasn't going to update itself, and I don't know why it picked the number it picked, or the version it picked. But obviously, when I included the other crate, that it was like, hey, we've exported this out. Like, if I go here and I go, hey, rand, yeah, you were using 7.3. Sample uniform. Sample with a distribution D sample. That's bizarre. I've never had that happen before, where it picked an old crate to begin with, because I just always wild in rand. That is just not what I was expecting, because like I was feeling it was different, but I was going like I was actively looking for the gen range that took in a range, but it just like didn't find it. So I was like, maybe I've just been doing it wrong. But no, I just had an outdated version somehow. I think this is why you don't wildcard things in. Okay, so generate characters. So surely that means that I can like, so normal distribution. Distribution, okay, first. I would want to see like let arms equal RNG dot gen range 0 dot dot 4. Okay, and then if arms equals 0. See, cactus gets a vector, so I can't just cheekily num arms. I'm going to say num arms. I'm doing it this way just because it means that okay, so we want to go for 0 dot dot num arms. All right. Okay. So we turn that into a vector. So that would mean like it. Do you sample? So gen range can only sample uniform. Interesting. But surely there's updated docs now, because I would. No, I went to them. Interesting. Rand docs open. Okay, so we want to search all of Rand for range. No. So gen random create. Rand. How do I search the crate though? Dependencies, crate, builds, platform, rand, rust. Okay. Rand. Okay. Fill RNG core. Feeble RNG. Right. Crypto. Sequence prelude. Distributions. Non-uniform distributions. I mean, we could do a weighted index, apparently. So, the question then becomes like a fucking... What does it say? So, the crate no longer includes other non-uniform distributions, including... Instead, it is recommended that you use either ranger or stars. Interesting. So what is choice weight? And then you gotta weighted indexes, new weights, unwrap choice. Let mute RNG equal thread random. Choose distribution sample. Item 0. B3 D7. So 50% chance of being A. Okay. I'm going to assume that it's somewhat fast. So weighted. Alias index? No, we just want a weighted index. So, well, first off, let's go to the weighted index. Okay, so cumulative weight, total weight, x sampler. Okay. So, weights, I into iter. So, does that mean we can say something like the number of arms is like, I want there to be 5 that is no, 1 that there's 0 arms. Well, actually, no, we want lots. We want 1 that's 0 arms. Maybe 2 that there's 2. Maybe no, 2 that there's 0 arms. 3, 4, 2, 1. 0, 1, 2, 3, 4 arms. Okay, and then we want to say distribution. So new. So first off, you get a result, because we iter through each iteration. We knew x next or no item. Total weight equals next and or borrowed cloned. 0 x as default. Okay. Total weight is not greater than 0. Weight invalid weight. Weights vec x with capacity iter size hint. Okay. Iter weights borrow total weights equals 0. Total weights 0. Oh. Okay. How do you sample though? When do you ever use weighted distribution? Distr is a sampler x sampler new sampler 0 total weight. Ah. Okay, then let's have a look. When I so this is what is this? Okay, sample. So we say choose weight sample and then binary search by W if W chosen less greater. Okay. Well, it's better than my implementation would have been. So dot sample. Dot unwrap dot sample. Dot sample RNG. So that should pick the number of arms that basically, what are this, sum 2, 7, 8, 9, 10, 11, 12. Right, 12. So, yeah, 12. So there's a, like, 8% chance that it'll have 1 arm, 16% chance, it's 8% chance it'll have 4 arms. A 16% chance it'll have no arms, so much more likely it'll have 2 arms, which hopefully will do some fun stuff for me. Okay, so gen. What am I doing? Just vibing away. So this should weigh our distribution of our arms. We're gonna need to use that in other places, but maybe not necessarily right away. So this is when we build an arm. No, it's when we build a cactus. So the number of arms is now weighted properly, and the height of arms is also weighted properly. Yeah, okay. So we would then, I guess, say, hey, run. This might even make it faster because of how the sampling works. Who knows? Bum, bum, bum. Okay. Well, you see, the cactuses are now really tall. Okay, first off, that's a hell of a tall cactus. We also apparently gave you a negative height, which is you know, not good. How have we pulled this off? Okay, well, let's just have a little squiz and be like, the number of arms. Well, you have 3. You also have. It's hard to tell how many arms they have. Let's fix that before we. Okay. So, what did I break? So, probably not the number of cactuses. This stuff's probably all good. We can probably not worry about the cactus shape. It's going to be in here. Right. We're doing a normal distribution. It'll be the normal distributions. So, first off, the height of the cactus. So this is cactus. So we calculate your height as a sample of the normal distribution. I'm gonna be like print line height. Alright, this is obviously gonna print a whole bunch of gibberish. Right. It's going to print a whole bunch of gibberish, but that's more to do with like I need to see if these numbers are coming out reasonable, or is it my standard, my normal, standard normal distribution. See, it says it's going to get a number 0 to 1. So then we times it by 0.6 and add 0.2. So at most it can be 0.5. Yeah, you take a really long time. Yeah, okay. You are getting negative numbers, which doesn't even make sense. It says it generates from 0 to 1. How am I getting a negative number? Okay. Samples of floating point number. Normal distribution 0 to 1. Okay. So, in a normal distribution, apparently. So we don't really want to get abs. Okay, so I don't want to absolute it because that just seems like a waste of time. We could add 1, but that gives us a total value of 2, I guess. Okay, so we times it by. Okay, what we would want to do is times it by half that value, 0.3, and add 1.2. So height's almost got up to 1, which is worrying because the 0.6 times 1 should have given you, so it shouldn't have got any higher than 0.8. So I obviously don't understand this normal distribution. RNG sample. Okay. You are returning numbers way too high. So adding 1 was not the right approach. Okay. Let's do no math to zero distribution and see what numbers it actually puts out. Because it could be that it's giving numbers between -1/2 and 1/2. So, we'll find out. Bum, 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 bum. The monstrosity, that is. Why are you getting, like... What? PDF -x times x divided by 2 dot expon 0 case. Zugadoo. Okay, well, what if we try making you an F64? It'd be really funny if that didn't go up, because it could be that because it's just casting. And then as F32. It seems unlikely that it's the cast, but I had that problem earlier today, that the casting from one type to another was causing bit overflows. Or it was more that it was -1 would be equal to 1, and then I was ORing. So it was not the cast, but the ORing that was the problem, but still. I don't get it. Aren't you supposed to... Okay. Like, look, you get all the way down to like -2. I thought you were supposed to be a distribution. Or is it normal distributions can go to infinity? Okay, so we need to do something which is just adding more math on top, but oh my, okay. So I think 32, because it's all you're doing anyway. Abs. Oh, what are the other distributions that we have? Normal. Skr. Lip. Normal. Logistic. Do they have a logistics? That'd be good. Actually, I think logistics is more likely to be either. No, it's most likely to be in the middle. Logistics. No, so it's not. It's log normal. Standard. Okay. Samples integers across the probability of 0.5. This is equivalent to but faster. Okay. Sample integers according to the geometric distribution with 6. This is equivalent, so standard. Wait, it says this can do integers. All values that can be generated are the form n times epsilon divided by 2. I don't get it. Why can it be numbers greater than 1? You were supposed to be my savior. X times x minus 2. Negative x times x minus divided by 2 exponent. You're good. Secret. Okay. The biggest value. So I've printed enough. I should be able to go like, is there any 3s? 3 dot. There is. They're obviously exceedingly rare. There's only a single one. Well, first off, we probably want to take the absolute. We'll take the absolute divided by 2. Which will make trees taller. Well, like it's going to result in the cactuses being potentially up to the size of 1.5, maybe more, because you know it appears that you can get any number from the normal distribution. Obviously not, because you can't get the exponents. But what is so what is the maximum size that a float can be without its exponent set? Wait, that seems backwards. That number's really small. Four? Maybe 4. I don't know. I mean, the sub-zeros, so it doesn't really make sense. All very small numbers. Okay, all of these numbers are small. So all the numbers are small. Probably this number. No, this number. 2, 3, 3.5. I don't know why this number is so large. It makes 0 sense to me. Because what are the sub-zeros? I'm just using on my other monitor. I've got this float calculator that I'm using in a video that you'll see soon, hopefully, to just try and work out what the highest possible value is. So it uses the 24, which is the mantissa. And so it's basically setting a random number inside the mantissa. Are these numbers getting bigger? A half, a 75, an eighth. Right. So all these numbers are less than 1. This is why it's doing this. They should be less than 1, even when all set. Do I get 1? Do you equal 1? No, you equal. Mantissa equals 2. Now, admittedly, apparently this is an incredibly small number. So, 1 point. This should be nan. Okay. That's the point. Even with none of these set, we get 0. We get 1. because it literally said 1. Which means it must be in the denominalized numbers. It's just setting the top bits. Oh, it's so confusing. How am I getting numbers? I'm literally just sampling as well. Alright, so we want to take the absolute of the height and then divide by 2. I think the maximum it could possibly be, I don't know. I have literally no idea. It makes no sense. I couldn't even guess at what the maximum value that could generate is. Because theoretically, on a true normal distribution, there's an astronomically tiny chance it'll generate infinity. But it says somewhere that it was using the top 24 bits of a 32-bit that generated. Okay, you can stop now. Look, now it's just generating lots of really small fuck-off numbers. Like, what? Why is this so small? And then there's one that's like, oh yeah, it was 1.5. So we take the abs, we divide by 2. And then we add like maybe and we add 0.05. I don't know why this normal distribution is not. It's distributing numbers greater than 1. I spent 20 minutes trying to fix this. I've run out of time now. Ready? Okay. Well, first off, we can probably stop printing that. Okay, so we got numbers. They do get greater than 1, which is a little bit like, what? Like, I don't want to use this standard normal sample, which is called self.sample for getting distribution. So I guess one more thing I could do is go, you have the inverse Gaussian, gamma, binomial. What is binomial? Binomial distribution. Wait a second. Binomial looks like a normal distribution. Don't tell me you're a normal distribution clamped between 0 and 1. Binomial probability and normal approximation. Binomial. Number of trails. Okay, let's read the binomial. The binomial distribution, binomial Bn. The distribution has density function fk and okay. So I don't get it. Binomial. So the number of distributions n, probably too small, probably too large. New by with the given shape parameter n, number of and p, probability of success. We're gonna go to your sample though. binomial. Okay, distribution sample. So if self.p equals 0, return 0. If self.p equals, return self n. If self.p is less than half self p, else 0 minus self p, let result at q equal negative constant binomial threshold is 10 square root threshold. What? Right, so binomials what I want for my number of branches, I guess. So binomials are always greater than 1. Like then like there's a 10% probability that you get 1, there's a 20% probability that you get 2, 30% probability you get 3, a 40% probability you get 4, all the way up, you know, and diminishing. So it's like the odds of you succeeding are proportional to the distance. So I guess we can tweak you and be like, I don't need to do this. I can just say you're a binomial. No, and there is no. Okay, so there's 5 possible states, and can we print num arms, which is num arms. Okay, and then I know a probability of like 20%. Dot. Can we get like a binomial distribution calculator? I feel like you don't want to use some of this stuff because it's gonna. So we're gonna say an n of 5 and a p of 0.2. What are the odds? Huh. Okay, so I said 6. So it's drawing like a little curve. We want to see maybe like a lower percentage chance. No, higher percentage chance apparently. Okay, so 5. Okay, so we want 4, I guess, because apparently even with an n of 5, you will still occasionally get 5. So apparently with a p of 3, there is a 0.8% chance of having 3. So, okay, 0.5. Oh, so that's like where the distribution ends up. So 0.5 is saying I want the middle to be about where it is. And so I'm guessing a 0.9 will be the other way. Yeah, 0.9 is like most of the stuff ends up at the other end. Okay, 0.45. 0.4. 0.4. 0.4 looks like a nice curve. And then we're going to see number of arms. Right, dot sample with RNG. Okay, so that should in theory print out numbers between 0 and 4. Just all the time. It's very, very slow. So stuff's still broken, but don't worry. So 0, 0, 0, 3, and there's a 4. So, yep, the number of arms that each cactus has a binomial. Okay. I guess I'll look at what other types of stuff you have. So, you have binomials. What else do you have? I guess we'll just go to binomial and read through the other. So, in your script. Okay, so your binomials. Couchy. So binomials, I'm assuming can't sample floats, which is probably a good thing. You have a sampler for U64. That's it. Okay, yeah, so it's a whole number distributor, which is exactly what I wanted. That's great. What is this one? Implement. We want to go distribution F. So F has to be a float. Okay. Sample pi times 10. So what is a culture distribution? So it is a distribution from 0. So it's sort of more likely to be in the middle than the sides, and it tapers down. Okay. Distribution. Stereotyped distribution. So this appears to be some kind of triangular distribution, which is not what we want. Exponential. Fraction. Sample flow input numbers according to their fraction distribution. That's interesting because that gives distributions closer to 0. Interesting. What numbers do you take in? If I wanted to create a new fraction, location. Oh, this is like a skewed scale shape. Gamma distribution. Okay. Let's just try going the other way. Let's go types. I'm going to Google types of distribution that are between 0 and 1. Okay, the normal distribution that has a mean 0 and a variance 1 is called standard. Okay, no. That have a range and with a peak. Okay. One possibility is a beta distribution. Do you have a beta distribution? Obviously not. Geometric distribution? Geometric distribution. Images. So a geometric distribution is just as you get further from 0, it becomes rarer, so it's definitely not what we want. A Gumbel, okay. Gumbel distribution. Okay, no, Gumbel distributions still have location and scale. Hypergeometric inverse Gaussian? Inverse Gaussian distribution? Okay, lib normal whatever this is, Pareto distribution. Okay, that is also not appearing to be correct. I need a distribution that's not going to get to not reaching 0. Parrot. Parrot distribution. Well, a parrot distribution definitely stops, so it's probably the best so far. So the parrot has a minimum, maximum, and a mode. Minimum, maximum, and a mode. Okay. So that somewhat works. That's interesting. Okay. Well, that's the best I've got so far, so I'm going to keep that tab open, I guess. A poison distribution? A poison distribution. I think you guys are just staring blank text while I'm doing this. I make such an entertaining streamer, don't I? Poison distribution. So, okay, gamma 6. So that just specifies the start position. Probability off. Okay, so it's sort of like it's a poison distribution. It's like a normal distribution, but with the center skew normal. Triangle. Triangular distribution. Yes, but does a triangular distribution end up being between 0 and 1? Minimum, maximum, mode. So a triangular does end up being between 0 and 1. But, like, it literally just makes a triangle. Like, look at this thing. It's just a triangle. I do want some curviness to my numbers, which I do. By the looks of the thing, I'm going to use the pert. And the thing with this is I'm pretty sure I could make like a lazy static sampler, which would speed up my code because I don't need to create the sampler every time. Unit ball. So maybe unit ball. Unit circle. Unit circle maybe. Unit sphere, utility, wire. Nope, okay. Okay, so we're gonna go to the desert. We're gonna go, okay, weighted index. Not needed, apparently. That's nice. We use a binomial. Who knows if the binomial is actually faster? I would think it is because the weighted actually tests everything. It does binary search through it, but it does test every possibility, whereas the binomial, I guess, cancels early. Like it just samples and done. Uses math. Standard normal. Okay, so we want the distribution, we want a parrot distribution. Okay, and then we want to come down here. We want to go, okay, so everywhere I say normal distribution, like when we sample a height, we want to sample we want to say, let sampler equal pert new. Okay, minimum 0.1, maximum 1.2. Mode. I don't know what the mode does. Mode. 0, 10, 50. So minimum, maximum, mode. Interesting. Well, we could go like a PERT calculator, PERT distribution calculator. And because everyone on the internet is amazing, there's like literally so many gadgets for generating PERTs. Task number. No. No, these are all fucking other calculators. PERT distribution. Alright, mode. I kind of wish it would say what the mode was. PERT shape. With this is equivalent to calling PERT shape with a shape equal to 4. PERT distribution. PERT distribution. So PERT distribution in probability and statistics. The PERT distribution is a family of continuous probability distributions defined by the minimum and most likely and maximum. Okay, values that a value can take. It is a transformation of 4 probability better than the 0. Okay, so minimum, most likely, maximum. Mode. I guess that's mode, isn't it? Let's just Google that quickly. Mode. Math. Mode. Math. Mode. The most frequent number. Okay. We're going to say the most frequent number is 0.5. Oh. 0.5. That would explain why the tables are different, because you want min, max, mode, whereas all the tables are min, mode, max, because the numbers need to go in that order. And then we would go sampler. Okay. Dot unwrap. Okay. So PERT. Let's just have a quick look. What do you just call with sampler? So you make sure that maximum is greater than minimum. And you make sure that mode is greater than minimum but less than maximum. And then you make sure that shape from 0, shape too small. Okay. Who knows how this stuff works? It's all beyond my math skills. We are doing a PERT sampling for height. So, I mean, outside of the average chunk time apparently being very slow, but I'm also printing shit, so it's not something we can rely on. Just gonna remove the print stuff. Okay, and then so each of these is every time I use the normal, I'm just gonna go sampler. Okay, wait. Why wouldn't we make custom samplers? I guess. Yeah. Well, I mean, if you're gonna pay the extra overhead of having to use the custom sampler, why wouldn't we just say new? Okay, so this is the height off the ground. So all of them will be 0.1 off the ground. All of them will be height minus 0.1 from the top. And then we don't unwrap. Takes 3 arguments. And the mode is going to be probably height divided by 2. Okay. That's actually really nice to distribute numbers. I guess that's probably why they invented this kind of stuff. You know, it'd be nice to have like a, I want numbers that are anywhere from this range to that range, but mostly in this range. So the minimum, this is the height. So it's a minimum of 0.1. Maximum of, let's say like 1.5. You can have really long arms, but most of the time they're going to be about 0.66. Okay, so with that, we have all our distributions set up, and apparently we no longer use normal distributions. Okay. Interesting. Okay, thread. Why did you panic? 19. Okay. You called unwrap on a task pool. Okay, so thread. Error, range too small. Okay, so apparently the okay, should have expected that one. Now only one of these can have a range too small, and it's the one that I'm dynamically setting the maximum. So mode is height divided by 2. Okay, and what is the minimum height? The minimum is 0.1, which means that in theory you could be putting 0. So, okay, so we want to take the max out of that and 0.11. Okay. So at least somewhere in the millions upon millions of chunks, you know that one, hundreds of cells, at least one of them would have had the nope, it's still saying error, panic. Result unwrap. R119. So U. Okay, and mode also needs to be the maximum out of 0.105. Why these numbers? Well, 0.1 is the minimum. 0.11 is my possible alternative if it's too small. I should probably make that a little bit bigger, but basically what I'm saying is if the height is too small, set a different height, use a different height. But it does make me wonder, maybe I'm generating a lot of small numbers. But why are you still crashing? That's where all the 19s are coming from. Where's 140? Probably unrelated. Well, actually, no, 140 is where I'm calling something. Okay, so what are you saying? Range too small. Okay. 0.2. 1.5. Why are you not working now? Panicked, yeah. It's interesting because that theoretically tells me that there are always like something else is wrong because it's always panicking. Let's print some heights. Print line HIG. I feel like you're always generating small numbers. So also, didn't we say that 0.25 is the smallest possible? Like the shortest possible height that a okay. We got like a... Oh, you panicked and it just kept going and going and going. You also panicked and just kept going and going. So we're getting heights that are... Thread panicked. Range too small. Okay. So when I create you and then you create you, when do you return range too small? If not, maximum is not bigger than minimum. Weird. Range too small. Okay. Max is less than minimum, or minimum or maximum is nan. Okay. So first off, if we make this 2.5, just all cactuses just have to be a little bit taller. It's still panicking. Well, apparently a lot of the cactuses are just taller now. We also probably want to say more like closer to 7.5. I am going to go let the dog in. I will be right back. Alright, so I need to work out why it's failing. So let's calculate the 3 numbers that I possibly could use. So it is... We are going to print line min, max, mode, right, and error, which is going to be min, mode, and then we want to say and what is it? No, it's called, it's a parrot, not a pat, parrot, new with these numbers. Okay. Okay. Go. So this should print me what the minimum, maximum, mode are. And also what error it gets. Because it's obviously something going wrong. Okay. F5, it crashes almost immediately. It's also just like Oh, right. It's probably to do with the fact that... Alright. Okay. So, minimum, maximum error, range too small. Except, how is the range too small? The minimum is less than the maximum, and the mode is in between. Minimum, range, beta, switched. Okay, unless there's another potential chance for it to fail, because it does do things like, okay, from shape, okay. Range, maximum, minimum, min plus shape times mode, divided by shape f from 2. Range too small. Okay. Alpha too small. Okay, so maybe that they're just too close together. Okay. Because you get an alpha, a beta, a gamma. Okay. If let error e equals okay, exit e. Okay. That should at least make it not spam the fuck out of me when it's succeeding. And obviously it'll only put like one error because as soon as the errors it crashes, but okay. So okay, minimum, maximum. Alright. I'm curious if maybe it's when the difference between these two numbers, because what am I saying, the mode? So the mode needs to be between them. So the mode needs to be the maximum between height minus 1 minus height minus 0.1. No. Height minus 0.1. So it's probably to do with the range being too small. If the mode, it doesn't make sense really, but alright, I need the mode to equal we need to let b height bh needs to equal this number. Put you up there. So we need to give you bh, and then how do we work out the mode? Let BM equals that, and then your BM. B underscore M. Alright, and then we're going to turn it here and your BH and your B underscore M. Alright, so the first test is going to be to use the same numbers we were using. So we're going to say height divided by 2 dot max 0.15, but I'm going to increase the range here to being like the minimum the height can be is going to be bigger. When did you say range was too small? I don't know. I'm going to say that's probably going to be the end of the stream for today. I will see you all next time.